I'm very happy to be the second part of our Singapore government double feature here. I'm actually at GovTech, so just like Economies. Hold on. Is it sound okay? Yeah? All right, sounds good. So, and I'm a Smart Nation Fellow, and I always like to highlight that the nation is smart. I'm just the fellow, right? So it's parsed as Smart Nation Fellow. And it's really interesting, doing cloud strategies, a lot of cool stuff there in GovTech. And part of my role is being an architect. I've been an architect for much of my career, and I like being an architect a lot. There's one downside of being an architect, though, and that is it's not so easy to explain to people what you really do. Right? There's like a lot of kind of different things, and a lot of people will actually accuse architects of sometimes living in their own little world. And today I'm actually going to vehemently agree with that, because I think architects should live in a little bit of a different world, and that is the world of the first derivative. And I'll explain what that means and why I think architects should be living in the world of the first derivative. First of all, though, when we talk about architect personas, right, especially in a technical audience, we often think about this guy, right? Everybody knows, right? The architect, right? And I think his name is actually the architect. Now, the stereotype there is, right? This is the person who knows everything, who makes all the decision, right? Who's the ultimate authority. And as many folks, who watch the movie closely know, though, that the major catch here is that this is not a human being, right? The architect is part of the machines and the whole story with Neo, etc., right? So this is great for the Hollywood movies. This is not as great in real life. You don't want to be the architect who claims to know everything and make all the decision, because that's not a very suitable model for mere mortals. There's another bit lesser known and very strange movie that also has an architect. And this character is called Anthony Royal, so at least he has a name. And that's the ultimate architect who has this idealistic, like utopian vision of what this skyscraper, right, the high-riser, what this high-riser should look like. And even though it's master planned and beautiful and has all the features you could imagine, it totally goes wrong and ends up sort of like an absolute misery and mayhem, just like sometimes the IT projects do, right? So, this is the kind of architect we've all seen, and this is also not the architect we really want, right, who has this utopian vision that doesn't translate actually into daily reality. When people look at me, they more often think about this kind of architect, the little bit of mad scientist, and I always joke, right, it comes a little bit from the haircut, and it also comes a little bit from the car I have, and we'll come back to the car stories here. I think, though, a little bit of mad scientist and architecture is actually well placed. Right? A lot of things go by structure and decision discipline, but also a little bit of creativity or a different way of looking at things is actually a great attribute for an architect. So now that we've seen like sort of very different characters of what architects are, it's probably time to think about why we're actually doing architecture. Right? As I said, it's not always so easy to explain what you actually do. Yet, architecture is a very important function in almost any organization. And the larger and the more complex it gets, the more important it seems to be that you have an architect. And the way I've come to define that is that I actually tell folks that I believe the main purpose of architecture is to provide options. And we're speaking of financial services organization here, so this will be crystal clear and obvious to almost everybody. This is the options pricing formula. Black-Scholes got the Nobel Prize in economics for this, right? This is how options work. For those who still have to do up their reading on sort of financial industry, I'll explain quickly. An option is effectively a way to defer a decision into the future at fixed parameters. The most simple example is you buy yourself an option to purchase a stock at a certain price, but you don't need to buy the stock today. You buy the stock in, let's say, 1 year. Now, the beauty of that is, so let's say it's $100, right? Just pick a number. The beauty of that is once 1 year later comes, whether to buy that stock or not, that decision becomes very easy, right? If the market price is less than 100, you buy it at the market price because, the option to buy it at $100 isn't really interesting. On the other hand, if the market price is higher than $100, of course you use the option, right? It's arbitrage at this point. If the stock trades 120, you have the option to buy at 100. Of course, you buy it at 100 and you flip it at 120 instantly if you so like. So deferring decisions into the future has an obvious value, right? Because if I buy the stock today, I'm down by $100. I'm down by the current price, which might not be $100, but I don't know which way it's going to go. Right? So deferring the decision makes the decision much easier because we have more information. And that has value. Right? And we know this in the options market. These options are not free because you can make money off it. Right? If something has a value, it also has a price to it. So let's translate this into IT, what we do. And I'm sure you guys, all of you have created and sold options to your business or to the other IT teams. A classic one is server sizing, right? When I worked in the financial services industry, we had a whole team that didn't do anything but just size servers, right? I look at all the requirements, right, and sort of figure out how many servers of what you need. And the guys had a really tough job because their work can only lead to one of two outcomes, right? Either the infrastructure is too big or it's too small, right? So either they wasted money or it doesn't perform. So a little bit of a tough job to have. Now, you guys know the architecture option extremely well that you can sell to those people. You can sell them elastic scaling, right? A scale-out architecture, right? You make things stateless, you make them scale out, you're an elastic infrastructure, right? That is selling the option. And that does exactly what this does. It has fixed parameters, but it defers the decision into the future. So if the app is a little bit too slow and it scales out, well, you add a little bit of hardware, right? If you have the inverse, reduce a little bit and you save cost. So this whole need to make this guess up front has gone away. Now the option, and that's what we have to remember, isn't free either, right? You need to build the application in a certain way. You need to move things to the cloud if you're not yet. You need some automation, right? The stateless kind of thing isn't always, right, the way your application functions, so there's a cost to that. So this is the second big reminder for architects. Having the option is good, but whether to buy the option, whether your business should buy the option, is very difficult for you to decide. Right? How do you know whether this option you have, this elastic horizontal scaling option, is valuable for the business? Now, we don't have this formula, right, in IT, but we can derive one thing out of the formula, and that's the little letter sigma that's there, actually the sigma squared, and that is the volatility. And the volatility tells us that the higher the volatility in the system, the higher the value of the option. And that makes intuitively sense. Think about it. Coming back to my stock example, right? I have the option in 1 year to buy the stock for $100. If this stock has never moved, if the stock price has never changed ever, it's always been $100 since the beginning of time, deferring that buying decision into the future isn't that interesting, right? Whether I spent $100 today or in 1 year, maybe I have a little bit of interest rate advantage, right? But in the end, it's not buying me much. If that stock is all over the place, right? If nobody knows where this is going, I could be losing all my money, I could be making 10x more money, right? It's all over the map, then buying the option is suddenly much more interesting, right? Because I have no idea what's going to be in 1 year. So fixing that price is highly valuable to me. And exactly the same thing is true for the scaling out, right? If this is an application, well, that's my hint that I talked too long for one slide. If I build an application that has a limited set of users, it's some internal application, right? It always does the same thing. It always has the same 20 users. The option simply isn't as valuable. Even though it's good architecture, you might say, right? But it's just not valuable, right? Because we know it's 20 users. Once we have the hardware for that, we're good. We never need to scale up, scale down. Versus if I build a mobile app or I run campaigns or do something on the web, right? That's highly unpredictable. This option becomes more valuable because there's volatility. Right? Now, if we put that thing together, it leads to a very interesting conclusion that I feel is often totally misunderstood. And that is, if you live in a world of high uncertainty, both agility and architecture are better suited for a world with high volatility, with high uncertainty. And too many people say like, oh, I'm agile, do I need architecture? I'm like, hold on, that's a funny question, right? Because if you're agile, the reason you want to be agile is because you live with uncertainty, right? You're in a volatile world. If you can predict everything, you don't need to be a whole lot of agile, right? But if you're not, and this agile thing works well for you, you also want to pay more attention to your architecture because these options that you can create, as we saw, are much more valuable in a volatile world. So in the end, first main message I want to give is architecture and agility actually go hand in hand. And the reason we like both is because they help us do better work in an environment that's highly volatile. And the last time I checked, our IT environment and our business environment these days is quite volatile. So both of these things are valuable and they go hand in hand. Now there's another sort of nuance to this, and that so deferring decisions has value, right? Because you have more information by the time you defer it. On the other hand, if you defer all decisions, it's a little bit difficult to get stuff done, right? You need to put some anchors in, you need to make some decisions. So here's another bad movie metaphor, and actually a television show metaphor. Anybody recognizes this really horrible, poor, non-intelligent television show? Takeshi's Castle, yes. So it's as low as television goes, right? This is about the benchmark. It's a sort of rather sadistic, Japanese game show that makes people do all sorts of, stupid exercises, and they always have a very sadistic bent. So here the bent is, this person runs over this pond, and it wouldn't be funny if all these stones were actually stones. Some of them are styrofoam. And you can sort of imagine in slow motion sort of how this TV show goes and sort of at which intellectual level sort of it targets the audience. I love this show, right? So basically, this person will run and will make a misstep and then go under in this muddy pond. Now, the reality is enterprise IT architecture is a little bit like this as well. You're not going to know what you're going to get, and you love having all the options. But if you're not willing to run, you lose the game also. And I think this is sort of dichotomy that makes architecture interesting, right? We have this intellectual framework of making options and deferring decisions. At the same time, you got to just take your guts and run. And often these stones are certain vendors, right? And with some vendors, you occasionally feel like you stepped on one of those styrofoam, right? Some product or some vendors. But in the end, as I said, standing still doesn't help. You need to move. Right? So it's an interesting contrast that architecture and architects live with. Now, the question we should ask is, do we always need architects, right? Or do we always need architecture? Eric Dörningberg gives an interesting talk. It's called Architecture Without Architects, right? You can do that. But when do we not need to have architecture? And I thought about this quite a bit, and in the end, I realized where I could most honestly say that you don't need an architect is if you're in an environment where nothing changes. Or on my clicker. Can we clicky? There we go. Right? If nothing ever changes, if you sort of have a little bit of a legacy standstill, kind of, the flowers bloom maybe, but if you have no rate of change, you don't need a lot of architecture. Right? If you got the thing working somehow, right, and it's working, and absolutely nothing changes, it'll probably keep working. Now, as you guys know, it's probably a poor assumption that nothing changes, right? Because always, a new library comes about, the thing has to scale, you have new requirements, you want to internationalize, somebody finds an exploit in the platform you were using, right? There is change always, but I would say if there wasn't any change at all, you wouldn't need much of this architecture. I think this sock is blocking my Wi-Fi signal. Or my controller, my clicker. So let's try that. Right? So in the end, if that is true though, right, that if nothing changes, you don't need architects and architecture, then it means that architects deal with change, right? They deal with uncertainty and change. And if we look back at sort of, 7th or 8th grade mathematics, right? The rate of change, how something moves, that's the first derivative, right? That's the first derivative of a function. And that's why I'm saying architects really need to live in the first derivative. And in this environment where nothing changes, the first derivative is just 0. That thing doesn't do anything, right? You don't need the architect. So hence, architects want to live in the first derivative. Now, it's all about change, right? The first derivative is not 0, so things are moving. So there are a few important lessons about dealing with change. And one of the problems in large enterprises where I mostly come from, right? I work now in the government. I worked for a large insurance company before, right? I worked as a consultant before, so I've seen a lot of large IT. The challenge they have is that the way they organized doesn't match well with change, and I'll explain that. The way IT works is all the change is packaged in a very neat little box, and that box is called project, right? And at the end of the project, something very important happens, right? At the end of the project, you go back to business as usual. And if business as usual is the end of the project, that means there's no more change. That means in their mindset that change is business as unusual, right? Business as usual is, you see the first derivative is 0, right? They're happy if stuff is not changing. And if stuff is changing, they get slightly nervous. And because they get slightly nervous, they have project approvals and budget reviews and steering committees and status reports, like all that kind of stuff, because we're a little bit nervous about this change stuff. So we try to control it as much as we possibly can. Now, if we live in a world of constant change, right, because as architects, that's the world we're used to, that curve looks very different, right? It's just like it keeps changing all the time. So the question is, where's your business as usual? Well, the answer is simple, is your business as usual is change. And that is exactly the inverse of the left-hand side. Now, in order to be successful in these two worlds, the skills are also different. On the left-hand side, basically, you need to be a good guesser, right? You need to know what you're aiming for. You need this target picture, the business case, right? The as is to be, we call it. On the right-hand side, there isn't a specific target picture. So on the right-hand side, it's much more valuable to be a fast learner, right? And that's why we work iteratively. Now, if you think that that is just like a play of words, right? I like to debug that quickly. We don't need to read all the pieces, but in the end, the left-hand side, which I also call the economies of scale, and the right-hand side, which I call the economies of speed, right? Because you need to learn fast, they're exactly the opposite. Right? On one hand, you can plan, you make a good plan, deviation from the plan is not desired, you're optimizing something that's already existing, versus on the right-hand side, you do exactly the opposite, right? You're experimenting, you're disrupting, right? You might be failing, variance is good because you're testing your hypothesis. It is exactly the opposite of each other. So if you try to increase the first derivative, right? If you're trying to bring speed into an organization, it's going to be a little bit harder than putting a Docker and Kubernetes in place, right? There's like fundamental mechanisms here that keep the organization from moving faster. And that's what I want to talk about a little bit, because as an architect, you'll realize that just making your tech faster is not enough. If you can't fix this problem, nothing will help, right? If your organization has a 6-month approval cycle for a server, whether I get that server in like a day or a minute or a second makes no difference. Right? So you need to be aware of how the organization operates. So let's talk about how we speed things up. And the first lesson that's very important is you cannot just speed things up by hitting the gas pedal faster. Oh, come on, I think my battery is weak here, sorry. Let me just click her, right? You cannot speed up just by putting the gas pedal harder. And that is because there's some mechanisms that work against you if you do that. And that's why we call this thing disruption. We're not looking to sort of go 10% faster in this exercise, right? With this whole digital transformation, right? If we want to compete with the digital companies, it's not a 10% game, it's a 10x game. And you're not going to go 10x faster by hitting the gas pedal. A good analogy that I'd like to use is, imagine you're on a steam train. And steam engines are wonderful vehicles, right? I mean, it's amazing how they function. They can go pretty fast. People build steam engines that go over 200 kilometers an hour. Right? It's like kind of feat of engineering. Cool stuff. Works, right? And then somebody comes along with a high-speed train, right? What is your instinct, right? They move faster than you do, right? What do? Well, you speed up. But if you have a steam engine, what does speeding up mean to you? Well, you know how to speed up. You put more coals in the fire, you put more water in the boiler, more pressure, right? More pressure on the boiler and more fire, right? Because that makes you go faster. And that works to a certain extent, but you know exactly where this leads, right? You'll burst the boiler, you'll blow the whole thing up. And if any of you, and I'm guessing if you do, work for organizations that are looking to disrupt, to change, to become faster, this will feel familiar, right? Like I worked at a company where the slogan was always do more with less. Right? It's like, well, how are we going to do that, right? It was like, just we need to speed up, we need to save a little money, just work a little harder, work a little faster, right? Is exactly this, right? Is put more coals in the fire, and that is, of course, not the way you speed up the organization, right? This will just lead to disaster. The second part that works against you is friction. And here's a picture where friction is a good thing, that those are the brakes in the car, right? It turns the energy into heat. That's where friction is good in the enterprise. Generally, friction is not something you want. And the reason friction works against you is that usually the harder you push, the stronger the friction gets, right? It like sort of works against you. And it has a second nasty property, and that is there is usually no friction department. Well, some people might say the legal department comes close, right? But generally there isn't sort of friction lives here, right? It's like, friction doesn't have an extension you can call. It's, hey, friction people, can you kind of ease off a little bit, right? Friction is everywhere, right? And that makes it really difficult, right? You cannot turn this off. So that's your second biggest enemy. Now, out of that, how do we do? Hitting the gas pedal harder doesn't work. Alone is not sufficient. You need to kind of loosen the handbrake, right? The reason your organization is not going any faster is because somebody is having the handbrake on, and if you just hit the gas harder, that whole brake will smoke up and probably seize and other bad things happen. So let me show you a few ways on how you can speed up. Some of them might be well known to you, but I kind of try to give a little bit of a spectrum on how you can speed up. And then we'll also see why speeding up is so important, because interestingly, speeding up does more than make you go faster. Well, we'll come to that. So have a quick look. So the first thing we'll talk about when we speed up is this thing. If you ask a project manager how you speed up the project, give me more people, right? Easy. Or reduce my scope, right? It's like patented, guaranteed recipe, right? And then there comes the worst one is this belief that if you compromise quality, you can speed up even further, right? If you just kind of quick and dirty, we call it, right? I would say, why is it not quick and clean, right? So it's quick and dirty, right? So the idea is if it's a little bit dirty, it becomes quicker. Now, the interesting idea is every software engineer knows how to delay a project, and that goes by putting a few extra bugs in the source code, right? There's like, if your job is to delay a project, right, the most sort of sinister way is, to make a messy code base, right, and put a few bugs here and there, and you're almost guaranteed that thing will not ship on time. Interesting, like two very different views of the world, right? And yet people believe somehow that this makes them faster. So we need to scratch this model, and we have a replacement model, and yes, with more car pictures, sorry. I'm just warming up for Adrian's talk. Like Adrian and I are a little bit car buffs, so you get the metaphor here. So we know friction, we already have. Friction is enemy of the state number one. Where there's frictions, the stuff doesn't move, and it's really hard to get rid of it. The second one that we don't think about it as much is inventory. The sort of layman's definition of inventory is it's stuff that you have built, so it has incurred cost, but it's not yet ready to sell, or at least not sold, so it hasn't generated revenue. Now, you don't need a PhD in economics to realize that that is not a very clever thing. It's not a great thing. Nobody likes inventory, right? The stuff you paid for that nobody else has, you paid back for. So it kind of, you're putting money into something that sits around. And the worst of these things is unfinished inventory. That stuff you put your money in, you're building, but it's not quite done, so nobody will buy it. Volkswagen is a great example. They once rented more parking lots near their big factory in Germany because the factory in Poland that was making the glove compartment lids went on fire. And they had 10,000 cars that were perfect, except they didn't have the glove compartment. So they were unsellable, right? CFO will not be excited about this. Now, translating this into software, we're like, those are the car company's problems. We're a software company, we don't have these kind of problems. We do, except they're less visible, right? That unfinished inventory, that is that long-running Git branch that a developer is working on that just needs that final touch, right? The glove compartment thing, right? It just needs to be merged back into the main branch, right? That is 100% inventory. If you think about it, any line of code ever written that is not in production is inventory. And that is not a good thing. So if you want to speed up, one easy way is not build for inventory, but build for the customer, right? Because that way you don't hold things back artificially. And the last one, and we know this well also, is another really, really clever way to speed up is don't build things that nobody needs. And I said need, not want, right? Because people want a lot of stuff, but needing and wanting are very different things. You see sort of this, blinky, blinky picture of this Mercedes down there. It's a gold Mercedes covered in Swarovski stones. I'm sure somebody wanted it because somebody paid for it, but I'm sure nobody needed it, right? So these are the three other ways we can actually speed up software, and they all make a lot of sense. And because of that, you all heard them before many times. This is exactly what DevOps is. This is taking the friction out, automation, CI/CD, all the good stuff we have, taking inventory out, that is lean, comes out of the manufacturing in the first place. So we just took what they already know. And the last one of not building stuff that nobody actually needs, that's agile. You prioritize by customer value. And if there's no articulated customer value, well, you don't build it, or maybe you build it later when you're clear about the value. So that's how you speed things up. Now, one interesting question we have is, what is a software system's first derivative? Because we're still talking about living in the first derivative. So if you're looking at a software system, what's the first derivative? Well, I guess the answer is written here. Your build and deployment pipeline is your first derivative. Right? It defines how quickly you can push a new release of the software. And if you think about it, that's why recently we spend so much more time thinking and talking about build and deployment pipelines. Right? We have continuous delivery, Dave Farley's book, and all these kind of things. Because in a fast-moving world, we got to think about the first derivative, right? And the build deployment pipeline, that is the first derivative. Also, if you look at the different cloud providers, right? We got Adrian here from AWS. I used to work for GCP, right? This is all the cloud builds. This is the Fargates, right? This is all the serverless, all the fast deployment, right? The high velocity, that is all first delivery stuff. I mean, we're all releasing new infrastructure things and many other services, but you've seen a noticeable shift from just like how well does my software run to like how quickly do I actually get it there. And that is a clear indication that also the cloud providers have understood that where the action is, and the action is in the first derivative. This is actually a picture that I used at Allianz when I used to work there, where we said, hey, our cloud journey is not just about moving servers from here to here, because in the end what that does is just build another data center or lease another data center. It is about having a full cycle of rapid deployment, feedback, etc. So that's where the picture comes from. So yes, so your software system first derivative is the build and deployment pipeline, and that's why we pay so much more attention to those. Now here's another second most important lesson, and I hinted to this, is that speeding up does more than just make you go faster. And coming back to my car jokes, this is actually my car, and I try to go the 88 miles per hour. As you can see there, the stupid speedometer only goes till 85. And unlike the movie, Back to the Future, nothing happens. So in the movie, yes, speeding up does make more things than just get you to go faster. So this time, architecture gets to be a little bit like the movies, because if we speed things up, we get more than just moving faster. Doesn't work in the DeLorean, I have proof here. And if anybody is wondering about the legality of it, it's on the German Autobahn, all legit, right? Speed limit is much, much higher. But yeah, if anybody wants to try, in real life here, nothing happens when you go faster, except in IT, it does. A lot of cool things happen. Let me explain to you what happens when you can move faster. That's not just about things moving more quickly. When I worked at Google, I wrote a fairly popular blog post down there. It was called Connecting the Dots. Because what happened, me as sort of digital messenger from the digital future, right? I would show up as like, hey, I traveled back from the future to tell you what it's going to be like, right? Kind of thing, right? Dear customer, and it's all going to be about speed, automation, feedback cycles, container Kubernetes everywhere, right? I came in to tell people all the great stories, and then the people sitting on the right-hand side told me, well, that's fantastic. I'm really happy for you, but I'm the CIO of a financial services or shipping or manufacturing company, and you know what? When I have to talk to my boss, they talk a little different than you do. They tell me about, hey, do I have a security breach? Because otherwise we're both on the way to the unemployment office, right? And that's not great, right? Especially if you did it and you're going with your boss, right? And you don't want to do that, right? The second one is, nobody wants to pay for IT that's not running. So make sure the stuff is all good, right? And please, please, please spend a little bit less money, right, while you add it. And I said, look, yeah, your stuff is great, but my world is over here. Now, as I promised, these things have a connection, and that's why they're called connecting the dots, right? So let's talk about how can you increase availability while reducing cost. Well, again, you need to think outside the box a little bit, but what's the most expensive server you can have? Well, the most expensive server you can have is the one that's not doing anything. Right? And I always say if you negotiate a 10% discount with your supplier, that equation hasn't improved a whole lot because it's still doing nothing for 10% less, right? So that doesn't help a lot, right? Now you would say, why would somebody have a lot of servers that are not doing anything? Haha, I know where they all sit. They're called warm standbys or hot standbys, or sometimes cold standbys, right? They're standbys. Now, why do you have standbys? Well, to increase availability. Because if something breaks, you want to have another part that's functioning. Fair enough. But if you were speeding up, if you can do things a lot faster, you don't need those standbys anymore. You just spool up a new instance from scratch. Right? Martin alluded to this a little bit. If that takes you 30 seconds, you don't need that warm standby. So in the end, as you can see here, and I encourage you to just read the blog post, is that you can see that the things on the left are exactly the ingredients you need to make the things on the right work. So this is why speeding up does a lot more than get you moving faster. It also makes your system more available while saving cost at the same time. Well, that's going to earn you some attention from a CIO or any IT manager, but it's not by pushing the gas pedal harder, it's by understanding a different relationship, by having a different view on sort of how the dynamics of your system work. And that's one the key message I'm trying to leave you with, right? If you live on the first derivative, it's a different world, so you look at things differently and you learn to unlock these kind of opportunities as opposed to just like, can we work weekends? Can we push a little bit harder? Because that's not going to work. Now, I also quoted, I already sort of mentioned Martin, so here is what I stole right from his talk that he gave previously, actually from the Q&A session, because I thought there was a really, really, really good insight. Right? Martin says, don't just look at the cost for running your system, also look at the cost for starting the system. Right? And he said, because that determines your mean time to recovery. Right? If I said, if you can have a whole new instance of your system in 30 seconds, and the thing goes down once a month, that's a lot of nines, right? I could do the math pretty quickly, but that's at least like 4 nines, right? So let it go down once a month. If in 30 seconds that thing is back up, right? That is darn good. And I like this quote so much, and I'm going to sort of use it a bit in a self-serving kind of fashion because it translates exactly back to thinking in the first derivative. Because while a system is running and things are in a stable state, the first derivative is 0 because it's the stable state. So as first derivative architects, we're interested in the beginning, right? Where the thing is ramping up. How quickly can it start up? What happens to the system while it's starting up? Because not all the services will start up in sync, and actually putting them in sync will slow down the startup, right? If you define a very specific startup order, it's going to slow down. Right? That's the curse of the word synchronization. I always say synchronization, sync comes from clock, and the way you get things on the same clock is when one or the other waits. Now, if you want to make things faster, waiting probably isn't exactly the best strategy, right? So you should let all the system components come on together and, for example, be tolerant enough that if a dependent component isn't there yet, the component waits and tries again. Right? You need to have those kind of mechanisms. And again, once you have a first derivative kind of thinking, that stuff will become relatively apparent to you. Right? Sequential startups will seem convenient, but we didn't become software architects to be very convenient. To be honest, there would have been more convenient jobs we could have picked. Right? Our job is to fix these kind of problems. Yes, and that's why look at the startup time. If you're trying to build resilient system, if you're trying to bring costs down, reducing your startup time, increasing that first derivative is a fantastic thing to do as an architect. Now, if you do this to the ultimate, you come to a world where recycling is a really great thing to do, except for servers. We love to throw servers away, right? Because we live in the software world, so we can sort of reincarnate them. But it leads to what I call one of the most important illities of today's world. We always talk about maintainability, scalability, like the architects do all the illities. And I think the illity that's really missing is disposability.
And the reason disposability is such a nice ility, because it makes you sleep at night. Right? If the thing breaks, you just throw it away, you make a new one as if nothing ever happened, right? You can toss stuff away, you can make new instances. So disposability is the thing that gives you the ultimate peace of mind. It's also a great cost cutter, because you can throw stuff away, not pay for it over the weekend. You can have a new built and deployment environment on Monday morning before you go to work. So disposability is a really nice thing. And in the IT context, it's actually completely environmentally correct, right? It's probably the only example where happy to trash service as much as you can, because it takes so much stress out of your system and out of the system overall. Coming to sort of close to wrapping this up, I have sort of one more major section I want to share. So here's an example, again, of how speed and quality and many other things relate to each other. And the reason I wrote a blog post on my own site at some point about this, where I said, automation, IT automation isn't there to increase efficiency. Because when we mention automation in a large enterprise context, people always think we automate to basically make manual labor go away. Because that's what IT has been doing for decades, right? We took something that was done manually, we automated it, and then we're like, well, sorry guys, that stuff is automated now. We kind of, don't need you as much anymore. And that's kind of how big business thinks about automation. Now, because of that, sometimes operations folks kind of feel like, oh, is it my turn now? Is this thing going to automate me away? And that is not a very happy feeling. I have a few positive answers to the operations folks. The one is, I've never seen anybody in IT who's not busy. So I wouldn't worry too much about that, right? Wherever I look, there's plenty to do. And the second one is, if you look at internet scale applications, their operational needs are actually much higher than traditional applications, right? Everything scales globally, infinitely, green-blue deployments, updates, right? There's plenty of operational stuff to play with, right? So I would never worry about it. But the more intellectual answer I give is, in the end, automation is more than just increasing efficiency. We're after speed. And we're after speed and quality, like repeatability at the same time. That's the payoff. It's not about getting rid of, people cost, right? It is about speeding up while keeping or improving the quality and increasing people's confidence. Because if you live in fear, that's the best way to slow down, right? If people are not sure about stuff, nobody wants to touch anything, you're definitely not going to go fast. So again, a different way to look at this. And very much sort of this first derivative point of view, the automation is there to make you speed up, and speeding up does more than just make you go faster. It gives you all these other benefits like repeatability and transparency. You can see what's going on in your system. With that, we come to the last part, and I hinted at this in the very beginning, right? If you want to really speed things up, it's not enough to get on a container platform, right? It's going to speed up your tech. But just speeding up your tech doesn't help if you don't speed up the organization. Now, I have another car picture, and I'll explain what that car picture means. So these are some pretty fancy cars, right? Especially in Singapore, they're going to be really expensive, right? And they can go really, 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 really fast, right? Now, how fast are they actually going? Not so much, huh? 25, if they push it pretty hard, 30, right? Now, many organizations are exactly like that. Right? Things just not moving as fast as they want. Now, what do the organizations do? What does the leadership say if things don't move as fast as they would like? They said, if we had only engineers like Amazon and Google and Facebook and Apple had, right? If we had only better engineers, we could also go faster. Now, what's the translation into this picture? This is as somebody saying, if I only had more horsepower, I'd be going faster. Makes no sense, right? You can put twice the horsepower in all these cars, they'll still be stuck in the traffic jam, right? So you can see how sometimes the answers that seem obvious make the least sense. Translating this back into an organization, that also means, because I do this a lot with companies, it's a little bit tempting when you go, let's say you look at an IT organization, and everything kind of is a little bit tedious, it moves slowly, stuff takes a long time. It's easy to fall into the trap of saying, well, maybe people kind of need to work a little harder. Maybe they need some smarter people, right? It's very tempting. So I want you guys to never fall into that trap. 99% of the times, it's the system, not the cars. It's the traffic jam, not the engine, right? So that means the people are not the problem. The way it's wired together is the problem. And that has a great advantage. That means it can be fixed with the same people. And if you let those cars run, they actually go plenty fast. Now, a couple techniques that I've tried and that I found to be useful if you try to sort of unstuck an organization, I find an interesting pattern. And I found it actually has a name. It's called dimensionality. I'm sure you guys have been in a technical discussion, particularly with architects, where basically the discussion sounds like the one person says it's a square, and the other person says it's a sphere, it's a circle, right? And they go square, circle, square, circle, circle, square, circle, square, right? And they can basically go at this forever, right? The argument is like, oh, you need to be serverless. Oh, you need to be containers, serverless, containers, containers, serverless, right? It's like they can play this forever. And then somebody says, hey, my VMs spool up quite as fast, just as fast, right? And then it goes back and forth. So you have rectangle, circle to no end. The best way I found to get these things unstuck is you need to get people to realize that they're looking at this just each from like 2 dimensions. It is actually like a tube, a cylinder. They're talking the same thing. That's why they can never get anywhere, right? Because they're sort of both right. But in the end, they're looking at this from just 1 dimension. And getting people to see things from an additional dimension is fantastic. And I'll give you some examples. Here is one on the left-hand side, the single dimension that is well known. I joked about it with quick and dirty. People have learned over time that speed and quality are diametrically opposed. They're on 1 dimension. You get one or the other. That's where the thing comes in, hey, can we just like reduce quality a little bit and maybe speed up, right? If you have this point of view of dimensionality, you know that these things are 2 dimensions. They have a relationship, and the default relationship may even be like this. So for the mathematicians, right, I'm just plotting the left thing onto the right thing, onto the 2 dimensions. It may be like this, but even there we had our doubts, right? Because we said, as the quality goes down, I don't think the speed goes up. There's a sort of thing at the end, but we can have whole different discussions. Like, how do we shift this? How do we move faster without compromising quality? How do we increase quality, without going any slower? Like when you see these 2 dimensions, you can have a whole different discussion. And that's what gets the organization to speed up. Not by having a slogan like, let's do more with less kind of thing, right? Because if that could have been done, they would have had that idea probably 30 years ago, right? It's not that easy. So I run workshops, and in one of the workshops, we did this exercise. We said like, hey, what examples do you know where the orgs that you're in or that you work with assume the things are opposites, but they're actually not? And the reason I like doing workshops is because I always learn the most. The list got very long very, very quickly. So speed, quality, that was my warm-up at the top. But so we have things like customization and low cost, right? People think if you customize something, it becomes expensive. Cars used to be like that, but are not anymore. You can have all the options you want. Micro customization. Standards and flexibility, very important one, right? People believe that if you standardize, harmonize something, it kills innovation. Not true. If you think about the cloud as a huge standardizer, right? HTTP and the internet is a huge standardizer, right? And yet both of those things have probably been the biggest innovation drivers we've ever seen in the last 20 years, right? It is not true. My slogan to that is I always say A4 paper does not cripple anybody's creativity, right? It's just you can draw on A4 paper, it's highly standardized. It boosts your creativity because you don't have to debate how big the paper is, how big the envelope is, how big the drawer is, right? All that goes away. So there's a very interesting list, right, where, change and stability, right? It's good to be risk averse, but risk averse doesn't need to be translating into change averse, right? People kind of, see these as opposites, but they're really, really not, right? And this is the dimensionality. And once you do that, you can have a whole different discussion in your organization. So you can also work on the first derivative of the organization and not just your technical system. Last point, so let's say you get this into gear, so you're speeding things up. It's not a linear process. Unfortunately, we're not driving a Tesla, right? We're driving sort of an old combustion engine car. We have gears, right? At some point, you need to switch a gear. You cannot just keep speeding up. And the way you switch gears, we know this actually in our architecture world is we need a clutch. We need something that sort of makes the old gear and the new gear work together. And in technical terms, we often call this an anti-corruption layer. Like we wrap the old stuff so we can build new stuff over here and keep the old stuff sort of behind this anti-corruption layer. Interestingly, works both for technical systems as well as for organizational systems. I was the clutch at Allianz, and I regularly meet people who also say, I'm the clutch, right? The people who make the old and the new system function together. Now we come to the advantage and disadvantage to that. So being a clutch is great. That's like a manager or a person who sort of deals with all the processes of the old world, but lets your team work as if it was in a new world. That's a great manager to have. The downside is the clutch is where all the friction, where all the heat goes, right? And that's one of the reasons why these famous two-speed architectures, where the idea is, oh, why don't you make the front end and everything will be like the new world? And you take your back end and everything will be like the old world, right? And isn't that a great solution? The reason I don't like these very much, because this is like grinding the clutch. This is like you're basically not shifting into second gear completely. You're letting the clutch slip non-stop. And if you do that, that looks like this. These are not the tires, that's the clutch burning, right? This is what happens ultimately, where if you have all this friction in one spot, it will just burn out. It will not work. And that's why the sad answer a little bit is for the folks who are the clutch in an organization, it's a very tiring job, and you cannot do that forever also, right? Because you'll be grinding between the two speeds. So it's important you shift into the second gear. You cannot let the two speeds sort of run at the same time forever. Wear your organization and your people out, and that is definitely not what you want. So with that, I think, we don't need this, hold on. No, this is I want, sorry. With that, summarize a little bit, quite a few points we've gone through, right? We started with the options, right? And what architecture means and why the options are important and how in an uncertain world the options are even more valuable, right? Then we realize, hey, the whole IT is built around business as usual, not meaning change. So if you want to bring change, you need to get to fundamentals, right? And to get to fundamentals, you can't just push the gas pedal harder or put more coals in the fire, right? Because that will burst the boiler. So instead, you need to think differently. One way to think differently is understanding what the first derivative of your software system is. That's the CI/CD, the build and deployment pipeline, right? That's why we're paying a lot of attention to it. And when we achieve that, the nice thing is we get more than just go faster, right? Speeding up does more for us than just going faster, because it has all these other things like disposability, reduce cost, improve uptime. It does many, many other things. Now, the thing is that itself still doesn't do the trick unless you also speed up your organization. And one really good way to do that is teach your organization to look at things from more perspectives, right? Show them the cylinder, not just the circle and the rectangle. And if you do that, you will see the organization speeds up. However, it doesn't speed up on a continuum, right? Every once in a while, you need to shift gears. When you shift gears, you need clutch, and that's a good thing as long as you don't let the clutch slip forever. So hopefully that's a nice summary of what the world of living in a first derivative looks like. If that was interesting to you, I also run a website. It's called Architect Elevator. I'm on Twitter. Yeah, I have a book around IT transformation, and generally sort of like to think and talk about this quite a lot. So I'll stick around for the rest of the afternoon so you can find me and ask me questions or any discussion you have. Thank you very much.